This is the intermediate algebra assignment for May 4th, 11.4 through 12.7. Here's the assignment up here. On 11.4, 17 and 18, here's 17, 5 over x plus 1 is greater than 0. 18, here's how you do 17 and 18. 3 over y minus 5 is less than 0. Your critical number comes from your denominator. If you would have had a y in the numerator, you would have found it also. But since we only have a y in the denominator, we set y minus 5 equal to 0, so y equals 5. That divides the number line into two parts, from negative infinity to 5 and from 5 to infinity. Which of those parts satisfy this inequality? So we try any number in the first interval. 3 is in the first interval. So 3 over 3 minus 5 is 3 over negative 2. That's a negative number. That is less than 0. So that interval does work. Then we try the other interval, 5 to infinity. I chose the number 7. Gives me 3 over 7 minus 5, 3 over 2. 3 over 2 is not less than 0, so that interval did not work. So this is the interval that did work. Then, on our quadratic formula, 11.5, we are doing, they are in standard form, where we can see the x-coordinate, x minus 4 equal to 0, x equals 4. 4 is the x-coordinate of the vertex. Very important point, this point here. So we put 4 in our equation. 4 minus 4 is 0, so 0 squared times 4 is 0, so we get 2. So 4, 2 is our vertex, first point. Then I go on either side of 4, 3 and 5. 3 and 5, one to the left and one to the right. I put them in. They give me 6 when I put them in the original equation up here. I had 3 minus 4 squared is negative 1 squared is 1 times 4 is 4 plus 2, 6. Same way with 2 to the left of the 4, 2, and 2 to the right of the 4, 6. I find those points. Then I graph those points and I get my parabola. X-intercept, where does it cross the x-axis? Does not. So there's no x-intercept. Y-intercept you always find by putting 0 in for the x. 66. 0 minus 4 is negative 4 squared is 16 times 4 is 64 plus 2, 66. Domain, look at the picture. It goes to the right forever and to the left forever. So negative infinity to infinity. Or we look at the original equation. There's no x's in the denominator and there's no radicals. So all real numbers for the domain. The range comes from looking at the graph. What's the smallest number for y? For y. It is 2. So bracket 2 to infinity. Then when we have a parabola in general form, we need to, and I miscopied it at first. I had this as minus 1 instead of minus 4, but it's negative x squared plus 4x minus 4. To find the vertex on these in general form like this, you put negative b, which is negative 4, over 2 times a, 2 times negative 1, so it comes out to 2. Then you put that 2 into the original equation, and it works out to 0. Then you put 1 to the right and 1 to the left of the 2 in to get on both sides. 3 gives you negative 1, and 1 gives you negative 1. Then I went 2 to the right, 4, and 2 to the left of the 2. 2 to the left of the 2 is 0, 2 to the right of the 2 is 4. Put them in, I get negative 4 when I put them back in the original equation. Then I graph this graph as seen down here on number 3. I have 2, 0, and then 1, negative 1, and 3, negative 1, and my points there. Notice it comes upside down. That is because it is negative x squared. So that's why it's upside down. Then my x-intercept on these in general form, you always set it equal to 0. 0 equals negative x squared plus 4x minus 4. I moved all of these on the right to the left side. Positive x squared minus 4x plus 4 equals 0. Makes it much easier to factor. X minus 2 and x minus 2. So 2, 0 is my x-intercept, which is right there, the vertex. And then I put 0 in for my x, and I get negative 4. Again, my domain is negative infinity to infinity, and then my range. Now this time, my y-coordinate has a highest point, 0. So that's negative infinity to 0, and then a bracket around the 0, because it comes up to it. Okay, then we move into chapter 12. 12.1 is 19 and 20 composite functions. Here's 19. 19 is right here, and these are the two things you're finding, and I found them on 20. So let's look at 20. F of x is negative 4x. G of x is x cubed plus x squared minus 6. When we are finding the first composite function, f, composite of g of x, that means we find g of x first, which is x cubed plus x squared minus 6 is your g of x. So we're finding f of that, which means basically that we are putting all of this, x cubed plus x squared minus 6, in for the x's over here, and there's only one x. So it's negative 4 times x cubed plus x squared minus 6, then times by negative 4, I get these numbers. Going the other way, g composite of f of x, I find f of x first, which is negative 4x, and so that means the negative 4x goes in for every x over here. Negative 4x replaces x here and here. So negative 4x, quantity cubed, is negative 64x cubed. Negative 4x squared is positive 16x squared minus 6. Then we go to 12.2, where we are doing inverse functions. We are writing the inverse. First step on number 1, we have x minus 3 over 2. We put it equal to y instead of f of x. Then we switch around, x and y. X equals y minus 3 over 2. Then, to get rid of I'm solving for my y over here. To get the y by itself, I multiply by 2 on both sides. So 2x equals y minus 3. Then I add 3 to both sides. So 2x plus 3 equals my y. And so 2x plus 3 is my inverse function. 35, cube root of x and then plus 1 is in the radical also. X plus 1 is underneath the radical. So y equals the cube root of x plus 1. Then I switch x and y around as I've done here. Then I've got to solve for that y. So I cube both sides. X cubed equals y plus 1. Then to get y by itself, I subtract 1. So x cubed minus 1 is my inverse. Then 49, I went through 66, although the assignment says through 64, just to show you the last two. 50, log to the base x of 8 is 3. Remember, that's x cubed equals 8 when you change it. Then you want x, so cube root of both sides, x is 2. 52, you put it 3 to the x equals 1 over 81. You want the same base on both sides. So 3 to the x equals 1 over 3 to the 4th. Then we bring that 3 up. 3 to the negative 4th equals 3 to the x. So negative 4 is my x. 53 and 54. 54, we make it 5 to the x equals 1 over 125. We want the same base if we can on both sides. So 5 to the x equals 1 over 5 cubed. So 5 to the x equals 5 to the negative 3, because we bring that up from the denominator. So x is negative 3. 56, log to the base 9 of x equals 1/2. So 9 to the 1/2 equals x. 1/2 power means square root of 9. So 3 is our answer. 58 and 60. 58 is written there, which means 2 to the x equals 16. Then if you can, get to 2 on both sides. 2 to the x equals 2 to the 4th, so x equals 4. 60, I mean. It's 2/3 squared. 2/3 times 2/3 is 4/9. 61 and 62. Okay, then 62 is x cubed equals 27, cube root of both sides, x equals 3. 64, this becomes 6 to the x equals 6 to the negative 2. So x has to equal negative 2. Then 65 and 66 comes from property 3, where you have b, and then up in the exponent you have a log to the same base b of x. So your answer is that x up there. Like 66, 5, log to the base 5 of 7. 7 is your answer. Then 24 through 28, we are to write these as one logarithm. If you have log to the base 5 of 2 plus log to the base 5 of y squared, when you're adding logs, that means you're adding exponents, so you could just multiply those two together. Log to the base 5 of 2y squared. Number 26, 2 log to the base 3 of 5 plus log to the base 3 of 2. Before we can put them together with multiplication, we first need to put this 2 back. Instead of being in front, we make it 5 squared, which is 25. Then log to the base 3 of 25 plus log to the base 3 of 2 is log to the base 3 of 50. Then 28, again, the 2 has to go back as the exponent. The 6 has to go back as the exponent. Then you can put them together by multiplication. So these three, putting together by multiplication or division as one log. Then the next page, okay, we have 39 now and 40. We have one log. We're trying to separate them down into separate parts. 5 and x are multiplied together and 4 is divided. So we can separate them. If they're multiplied or divided, we can separate them. Multiplication, we add the logs of the two things together. Log to the base 7 of 5 plus log to the base 7 of x minus log to the base 7 of 4 because of division. 42, same way. Log to the base 9 of 7 comes first, minus log to the base 9 of 8, because you're dividing it, minus log to the base 9 of y. Number 44, log to the base 5 of x divided by y to the 4th. We can separate those two because they're divided. Log to the base 5 of x minus log to the base 5 of y to the 4th. Also, this y to the 4th, the 4 can be moved down in front.